And I'm actually back. It's incredible because today things to be working. So we are ready to proceed. So let me tell you what's going to happen now. This is also going to be a bit of a special unit, this what follows. Why is it special? Because this is going to split the class in two. Half of you are going to be bored, like you've already done that in data management and modeling. That's just a brush up, brings back to the top of your minds all the knowledge. And then there's going to be another part, probably of you, who are going to be completely scared. What, normal forms? What are normal forms? I've never heard of this. Don't worry, that's also why I'm doing that, to give you a high-level impression of what is done in the database lecture on the bachelor's level. So don't be worried either way. If you're bored, don't worry. I hope next week will be more exciting, or even tomorrow. And if you're scared, don't worry, because this is going to be the content from SQL relational databases, but it's not a strict dependency. The only thing I would like you to do is to learn SQL. It's really not such a difficult language to learn. Business people use SQL, not just computer scientists. So that's my goal for you, learn SQL. And if you don't understand everything, that's totally okay. It's really using SQL that is the what you get out of this right here. Okay, so now I'm going to proceed with caution. So this is what is taught typically at the bachelor's level in computer science curricula, especially in German-speaking countries. We saw in a conference once discussing between educators that it seems Germany, Switzerland, Austria do it a bit more than in the US or other countries. It's basically the relational databases, all the theory behind this. Funny, because I'm actually being asked, you don't see it, but Zoom is asking me to confirm my speaking language, and my accent is so strong that he thinks I'm speaking French. But anyway, as long as you understand me, that works. All right. So this is Edgar Codd. I have, in French, we say a cat in the throat. German people say a frog in the throat. So forgive me for this. All right, so Edgar Codd, he is the researcher who revolutionized database systems with data independence. And he's at the origin of all the systems that became Oracle and so on, because they are implementation of his ideas. There is a seeding paper. It's on the Moodle if you're interested, so you can actually look at it. Historically, it's very interesting to see at the way that he explains this. So this is Edgar Codd. And the idea of data independence, again, I'm repeating, but there's a lot of value in repeating because then you remember better. It's data independence. What this means is that I have a logical model that everybody understands, tables, rows, columns, Excel, spreadsheets, right? Everybody understands that. And then there is the physical storage. It's a little bit grayed out in here because that's actually not important. Well, it is important, of course, because otherwise it wouldn't work, but it is not relevant to the final user. The final user can just focus on the data model. So perhaps the physical storage, as is shown here, is a file system on your laptop or on your computer, single machine. Perhaps it's a clay tablet. That's perfectly fine. This is how it was done back then, and it worked pretty well. Perhaps it's a spreadsheet software, maybe not as full-fledged as a real relational database system, but maybe. It could be a hard drive. It could be a cluster of machines, data center. In fact, we'll have that in this course. It could be DNA. I told you they are doing that. But there is one thing that didn't change. You notice? There is one thing that doesn't change here. That is the upper part. And this is why the idea is so brilliant. Because the users don't need to adapt. It's still tables. It's still SQL. So this is extremely valuable. And by the way, since you can change the physical storage, you can also keep improving. So what users notice is that without changing anything in here, things just become faster. There is an update, and suddenly it's twice as fast. Right? That's because optimizations were done in here. So that's the power of data independence and why I'm going to repeat it so much. Then you remember the data shapes. There's 5 of them: trees, tables, graphs, cubes, and text. But now text is actually, we understand that these are actually vectors. And just for this lecture, today and tomorrow, I'm going to be focusing on tables. But we'll see for the rest of the lecture that data independence also applies to the other shapes. Even vectors, because the user just talks with ChatGPT. That's as data independent as it gets, right? So it's the same idea. But anyway, tables, just tables for now, because we can learn so much from them. So first, the idea when you build a system like that, a database system, is you're going to have 4 levels. 2 physical levels, storage and compute. Storage is where you store the actual data. The user doesn't need to be aware of how, you just store it somewhere. There's the saying, information is physical, from physicists, so you store it. Then there is compute. Yes, that's absolutely a noun. People say compute, so the people who use AWS, Azure, and so on, they really say compute to designate the resources that you rent, machines, CPU, and so on. So compute, that's the actual software so this is the database. This is the database management system, and then you have the logical part. The model is basically what makes a table a table. The rows, the columns, the normal form, the primary key, and so on. Get a bit into it. And then you have the language. In the case of tables, it's undisputed. Nobody in their right mind would argue that there is any other language than SQL to query tables, right? It's totally accepted today. I cannot say the same thing about the other shapes, sadly, but for tables, this is undisputed, that it's SQL. So let me dive a little bit. What is a model? Well, we need to say 2 things: what data looks like and what you can do with it. It's a little bit like cooking. Do we have people who cook here? Right? It's the same. You need, what you have in a cookbook, you have the ingredients section that tells you what you need for baking your cake or cooking whatever you want to cook. And then there is the recipe that tells you what you're supposed to do with it. Right? So this is it, what you have in a data model. So mix, pour, break, dry, bake, grill, and so on. These are all the things you can do to cook. And we'll see with tables, you can project, select, group, join. We also have verbs for tables. All right. And so now where the magic happens, by the power of data independence, is that the logical level is not going to change. We just swap that part here, the compute and the storage, we'll exchange it for a data center. But this is not going to change. The language and the models will still remain the same. But I added here cubes, trees, graphs, and so on, just because it's also true for these other shapes, right? Basically, we keep the language and model the same, and we just swap the physical layer, and it just works in a way that the user barely notices the difference, except that suddenly they can query petabytes of data, and it's fast, as opposed to megabytes or gigabytes on a single machine. All right, so what is a table? I'm just checking the time because I want to make sure that I'm letting you go on time. So let me throw a few words at you, because I told you it would be scary, but I still don't want to scare you too much. So this is a table, and these are a few synonyms. You can also say it's a collection, you can say it's a relation, and mathematicians might already see why, because you can see it as a mathematical relation, or a relational table, right? So there's plenty of names you can give to it, but this is the one most important concept in the model. Then we need a name for the rows in the table. There's plenty of names, it's all synonyms. You can call it a row, a business object. Business people call it business objects. So they like to say there's business objects in your collection and so on. It sounds actually very, very good. So you can call it a business object if you want, or an item, an entity, a document, a record, a tuple, a map. There's many, many synonyms, right? So this is a row. For example, if you have a table with people, then one row is one person, right? A list of people. Then you have the columns. So you can call them attributes, fields, properties, keys that depend on the context. all means the same. Depending keys is, for example, you might be surprised because there's also primary key. That's in the context of JSON, for example. In the JSON, the attributes would be called keys in JSON. All right, so attributes, let's say. And then some of the attributes are special because the attributes identify a record. Imagine a list of people where one of the columns is the AHFAO number, the social security number. That is special because that identifies a person. We call that a primary key when that happens. Could be several columns. For cars, for example, you have the canton plus the number. That's two attributes that identify a license plate. Some people call it row ID name key instead of the attribute, so just be ready for the flexibility, all right? And then we have the single values. Some people call them scalar. If you're a mathematician, that's a little bit like when you have vector spaces, there's the vectors and there's the scalars, right? With tables, it's a little bit the same. There's the scalars and there's no vectors, but there's tables. So you have the tables and the scalars. And the scalars are really just the individual values. We also call them atoms. You know, when it's atomic, can be a string, a date, a number, and so on. Some people call it a cell, a characteristic, a fact that really depends on the context. So let's say a value. Nothing scary right here, right? It's clear for everybody, I assume. Tables, rows, columns, primary keys, and values. Now, I'm going to continue that tomorrow because there's only 2 minutes, and I really don't want to scare people to the point that they don't come back tomorrow. So I'm going to stop right here. You get back 2 minutes of your time. If there's anything write to us, I'll see you tomorrow at 9 a.m. It's not this lecture hall, it's the one behind right there. See you at 9 a.m. in the lecture hall or on Zoom. Thank you very much. Goodbye.